So let's continue with them. Actually, this question is important. Jeff is currently working in an IBM company, intent-based networking, and the question, what exactly IBM's, so intent-based networks, tries to achieve, and what machine learning can provide for IBM?
Great questions. Actually, I have a slide, but I cannot share it. Doesn't matter. So if you look at intent-based networking, the idea is to provide full life cycle. So you express your intent, magic happens, and you have working network. Problem parts are really intent consumption. So today, if you look at any company who kind of define themselves as intent-based, they all provide kind of sometimes intuitive, sometimes less so, but we need to provide user interface and workflow, which is not really native to intent-based networking. I mean, you start thinking from how you define a service. So this is first point where machine learning could help, specifically natural language processing. How do you take business concept, how do you take high-level abstraction and convert it into something that could be used to instantiate networking? This is very early. This work doesn't exist today. Personally, I find it very interesting to look into northbound APIs towards an ABN system. So this is one place where machine learning can potentially. If we look at machine learning in general, usually you see kind of two major things. One is unsupervised learning, so you're looking at data, you try to find something interesting. Another one is supervised data, machine learning, where you know what happened, you know the result, and you try to compute highly probable result based on the previous data. So you reinforce your learning, and every time you're not done correctly, you increase the weight. So this is how you get to the right result. So if we take view of intent-based system, it has a number of phases. It has intent consumption, intent modeling, intent instantiation, and validation. And it's very important to have all these phases built together because intent consumption gives you ability to create right expectations. So for example, if you are building BGP fabric, you know that there are going to be BGP sessions between every node. You know what your next hop are going to look. You know all the semantics, so you don't need unsupervised learning. You know exactly what you're looking for. However, what you don't know, what would it mean if next hop in a route changes from one to another and does it every second, right? So there's a lot of operational states and data that very difficult to understand, especially at scale. In this case, if you can provide post-mortem, so after you figured out what has happened, and your system actually has learned, if I see this 40 event, they mean one particular thing, this is great help for root cause identification. I think this is where machine learning is really going to shine. So it's really a sub-part of intent. It's not a replacement because you still need the context. You still need the intent because you reason within the intent. But ability to understand changes at scale, we humans, we are extremely bad at it. So this is where machine learning, I believe, going to shine.
Let me just repeat what I understood. By the way, you just described supervised and unsupervised learning, which is the highest, let's say, structures of the machine learning. Lots of other things like deep learning, etc., comes under this either supervised or unsupervised learning. Like supervised learning, what we know, we put into the algorithm, and what we want to know, we can understand. So basically, cat example, we provide lots of cat, dogs, etc. Then ask the algorithm, okay, is this cat? So it can understand from the previous data, but we need to put lots of data. Now my question, then Jeff, we need a lot of data, and how intent-based in the IBM case, how you will provide so much data to the system can get some predictive result.
So there's traditional approach of building data lakes. So you get all the data you can, tens of terabytes a day, and you try to run some algorithms on top of it, employing techniques of clustering. So there are many things you could do with it. The question whether it's worth doing it, because now you're paying for storage, for cooling, for whatnot. You also need to provide network, which in this case could be of size of your production network. So if you use out-of-band network, imagine you're building second network just to collect your analytics. On another side, in intent-based system, there's closed loop. So after you define the service, you know exactly what it is. So in this case, you could only focus on data that's important. So for example, counters are kind of abstract data, right? It's important to know anyway. So you you do it. However, on itself, the fact that load on your interface change from 10 to 15% is meaningless unless you understand the context. Maybe introduce new service. Maybe link went down somewhere really far away, right? So the combination of context provided by intent consumption, really limited data consumption in terms of analytics, and then ability to either correlate one event to another or run supervised learning on top of it, I think it's much better, much more realistic approach.
Loss of correlation also can happen. Like, okay, if the, let's say, temperature goes this level and maybe another event, if it happens as well, we will see interface down event. It can understand lots of, after this loss of correlation. In this case, maybe clustering technique like under the unsupervised learning can help, right? So in IBM,
yeah, absolutely.
Yeah.
But you can absolutely cluster data today and figure out that you see, I have really good slides on it, but you can see that something has happened. For example, interface went down or the session flagged. So you can actually correlate symptoms to something. But the question is then, is it really significant? If link went down and I have 16 links up, is it significant? Is it going to impact particular customer, particular application? So the context here is fundamental to really identify data as either actionable or just for information, right? And this is where value is coming in. I mean, there's a lot of data points. There are billions of data points out of middle-sized network. The question, what do you do with them? How do you make data actionable?
So it was nice as well. Just also let me verify the last thing about this. So in IBM case, then we can take the advantage both from supervised as well as unsupervised learning. Is it?
Yeah. So I would say supervised is much more natural if you build proper postmortem analysis into your system. So if someone after an event can describe what was the root cause, what were the symptoms, it's very easy to apply supervised learning to this kind of information. So I'll give you a very simple example. Optical vendors, they all preach, we do machine learning now when your power level on optical hits particular level, we know it's broken. Sorry, I knew this for 20 years, right? So I just needed to collect it. However, what machine learning gives me, now I don't need to go into my system and say, look, when it reaches 72%, it's broken. It can actually learn based on past events. If optic of particular type reaches particular thresholds, probably it's broken. So you see, the statistical analysis been for a very long time. We could do this before, but now you can automate this loop and fine tune it. For example, if it reaches 69%, it's going to break. It's not broken yet, but probably you need to replace it. And this you couldn't do before because there was not enough data to correlate.
Yeah. Data as well as computation power.
Yeah, I mean, computation power was always there. It was more expensive.
It was expensive, let's say.